Today we're looking at a process called completing the square, which looks at going from a sort of general form into a vertex form for a quadratic. This process is going to be strictly procedural and will not really have a lot of background information why. And so looking at three different cases today, going from maybe a simpler to a more difficult, let's look at a case like y equals x squared plus 8x minus 3. How do we turn this from a sort of a standard form into a more specific vertex form? Well, the process for completing the square is trying to literally complete a square. The first thing we want to do is focus on the first few terms and leave out those singles. So that's subtracting 3, just leave that off to the side. And what we want to ask is, how can we make this a square? Well, the specific process is to take that middle number that's attached to the x, simply divide it by 2, which is a 4, and square it. 4 squared is 16. So by simply writing in the number 16, we have essentially changed the value of this equation, of this function, and so we must balance that by subtracting a 16 afterwards. So the first step is to complete the square, and that is done. We can write this in a more simpler form as something squared, and if you factor the trinomial that we created, it can now be written as a binomial squared. The fastest way of going about this is by taking that middle number 8 and simply dividing it by 2. X plus 4 times x plus 4 makes x squared plus 8x plus 16. Cleaning up the singles, we have a negative 19, and we are in vertex form, completing the square done. So this is your most basic form when the number in front of the x squared is a 1. As we move on to a more complex example, let's try looking at an example 2, where maybe there's a number that is out in front. It complicates things slightly. So let's look at an example like y equals 2x squared plus 12x plus 7. Well, we have the same similar starting place. We're trying to make a perfect square out of those first two terms, and we leave the singles out. So we have a 2x squared plus a 12x, and we leave the singles out. But what's different about this is that we're going to actually take that 2 that's out in front, and we're going to factor it out. The problem is we can't really create a perfect square trinomial with that 2 in front because it's not a perfect square. So let's factor out a 2. What we're left with is an x squared plus a 6x. We'll leave our space to create our perfect square trinomial, and we can now add in the number that makes it perfect. So take that middle number 6 divided by 2 is a 3. 3 squared makes a 9. And now we have our perfect square trinomial, but we just changed the value of this function. So let's balance it out. Important to remember that the number we wrote is a 9, but its value is a positive 18. We balance that with a negative 18. A very common mistake is to simply say, oh, I wrote the number 9, let's balance it with a negative 9, but that would not balance the true value of that number. So we can now rewrite this in its vertex form, factoring this perfect square trinomial by taking that number 6, dividing it by 2 to make a 3. We can write x plus 3 squared minus our 11. Most people have trouble going from this perfect square trinomial to the binomial squared because they're wondering, how did that x squared become an x? It's important to note that what we're actually doing is factoring that perfect square trinomial into a binomial times a binomial and writing it as a binomial squared. So this is the level 2 difficulty when we are looking at a coefficient a, like this number 2 that was in front. So going on to maybe a third level of difficulty, where we have a negative in front. So let's say negative 2x squared plus a 6x plus a 1. It's the exact same procedure, it's the exact same steps, but it can be a little bit more tricky. So let's factor out that negative 2. We're left with an x squared minus a 3x leave a bit of a space, and then we'll leave those singles out as we always do. So, noticing immediately when we try to make this perfect square trinomial, our first impression might be that we have a number that is not nicely divisible by 2, making this, again, much more challenging. So let's take that -3, divide it by 2, and square it. Well, we're taking the number -3, dividing it by 2, and squaring it. That as a fraction can be written as a positive 9 over 4. And that is a perfect square trinomial. We can balance this 9 over 4 by taking its value, which is a -18 over 4, and balance it with a positive number, positive 18 over 4. That is, again, making this the challenging part. So rewriting this as its perfect square trinomial, we have a -2 that is hanging out in front of something squared. Simply by taking this middle number, dividing it by 2, so -3 over 2 makes this our perfect square as a binomial squared. Cleaning this up on the right side is a 4 over 4 plus an 18 over 4 makes a 22 over 4. And that is completing the square in its most complex level.